Good afternoon from Fairfax, Virginia, outside of Washington, D.C. My name is Pierre Kasha. I'm the director of the Decision Analysis Partners Postal Practice, and I would like to welcome you to our third postal webinar of 2013 on evaluating and implementing delivery sequencing. With me is Bernard Markowitz, our managing director.
Good morning.
A quick few words about Decision Analysis Partners. We are an independent consulting firm active in logistics, supply chain, telecommunications, and the postal service. In the last 5 years, we've delivered over 60 projects in all areas of the postal industry, from operational improvements such as delivery sequencing to market and financial analysis, standard development, and labor planning and analysis. We have scheduled 8 free postal webinars for this year, and we invite you to join us every month. Our next webinar will be on measuring performance, and it will take place on May 16 at 10:30 a.m. Eastern Daylight Savings Time. I hope that you'll be able to join us then. Some rules for asking a question. The presentation will last about 40 minutes. If you'd like to ask a question during the webinar, please use the chat window, which can be accessed through the pop-up menu at the top of the screen. We will select the questions at the end of the presentation and answer them together. The materials after the webinar. We will make available both the recording of today's webinar and the slides that were used in the presentation. We will send you an email with links to these documents shortly after the webinar, and you will be free to forward them to friends and colleagues. Let's take a look at the webinar outline. As you can see on the slide, we will begin with a description of automated delivery point sequencing and how it is performed. We will then talk about the criteria that must be evaluated to determine whether sequencing applies to you, or whether you can take measures to justify implementing a sequencing program. We will then talk about considerations and alternatives for implementing sequencing. And finally, we will cover briefly next steps. Automated delivery point sequencing. In general, automated delivery point sequencing is designed to reduce operating costs and primarily delivery carrier labor costs. In many emerging economies, increasing levels of wages for mail carriers can make this an attractive proposition. Many other benefits accompany the implementation of automated delivery point sequencing, such as improved service, improved address management, the possibility to further develop advertising mail and generate additional revenues, improved performance measurement, simplifying a carrier's task, and reduce delivery errors. These improvements essentially help the postal operator improve discipline and precision across its distribution network. However, delivery sequencing has significant impacts on operations and on the network. There are many hardware strategies, such as what kind of machines and how many should be procured, and where should they be placed. Sorting, distribution, and transport operations will also be impacted significantly. As a result, automated delivery point sequencing and its elements should be carefully evaluated. We will talk about this in the next step section. So, what is delivery point sequencing? Delivery point sequencing is an automated process to sort mail in the sequence in which a letter carrier walks his or her route, or in the numbering sequence of apartments in a high-rise building. For instance, it sorts the mail in the same order as indicated by the red dots in the image on the right. The automated mail sequencing equipment is driven by software, also known as sort schemes, and delivery route sequences that uses the complete address to sort the mail into bins also known as stackers. Following several passes into the machine, these bins are emptied directly into trays that maintain mail sequence. Depending on the sequencing strategy, whether mail is sequenced in a central sorting center or in a post office or delivery unit, mail is then transported and handed directly to a letter carrier for delivery to the street. In the absence of delivery point sequencing, a letter carrier would receive his or her mail in a random order and would have to spend a significant amount of time at the post office to manually sort mail according to walk sequence before they could go on the street. So what are the benefits of delivery sequencing? As you can understand, the main advantage of automated delivery point sequencing is that the letter carrier spends less time preparing his or her mail manually at the post office and can thus spend more time on the street delivering the mail. As a result, a letter carrier can cover a broader geographic region on his or her route on any given day. This naturally helps reduce the total number of carriers and helps reduce labor costs associated with the last mile or last kilometer for the delivery of mail. These costs generally represent at least 50% of the total operating cost of a typical postal organization, and they can sometimes go up to 70% of total operating costs. The top part of the slide illustrates that when automated sequencing is not implemented, carriers spend about half their time in the post office and the other half on the street. The bottom part of the slide illustrates that when automated sequencing is implemented, carriers will spend approximately 2 hours per day in the post office and the balance on the street. So, how does mail get sequenced? It usually takes 2 or 3 sorting steps or passes. In this illustration, we are assuming that the sorting machine is composed of 4 bins. We're also assuming that we are sorting mail for 3 carriers assigned to the same postal zone, which means that an upstream sorting operation has already sorted the mail to that zone. In the first pass, each bin is assigned to one of the stops a carrier makes along his or her route. Those stops correspond to the red dots we showed on the previous slide. The first mail piece happens to belong to carrier 1 and to be on the first stop of his route. It goes into the first bin. The second mail piece belongs to carrier 2 and is on the third stop on his route. It goes into the third bin. The third mail piece belongs to also carrier 1 and is on his fourth stop. It goes to the fourth bin. The fourth piece belongs to carrier 1 again and is on his second stop. It goes to the second bin. Continuing through the first pass, all mail gets sorted into its corresponding stops. We say the mail is indexed before the second pass can start. The second pass is a sequencing pass. Mail gets now sorted by carrier in their walk sequence. As you can see, the first stops for carriers 1, 2, and 3 are now in the front of the bin. Now the second stops on the carrier routes are sorted in the second position in the bin. Next, the third stops are in third position, and finally, the 4 stops are sequenced last. The most important takeaway from this illustration is that pass 2 cannot begin until all the mail for that zone has arrived to the sorting center and has gone through pass 1. If any mail for that zone arrives after pass 2 has begun, it can no longer be sequenced during that machine operation or run. This mail is likely to miss its service commitment. Coordinating pass 1 and pass 2. All mail destined to the same postal zone coming from multiple locations must first arrive to the destination sorting center before the sequencing sort can begin. In this slide, mail is dropped on day D at 2 different post offices in the country. The mail is then entered into the origin sort center, also on day E. It gets sorted by zone, then transported to the destination sort center. Given that travel distances are not the same, mail arriving early must be staged until all the mail for that zone has arrived. It may wait until the early hours of the next day, day D+1, so it may wait until then. When it has all arrived, the delivery point sequencing operation can take place on day D+1. It is then transported on the morning of D+1 to the destination post office before it is delivered to its final destination. This illustrates that because the sequencing operation must wait for all the mail to arrive, the processing window, that is the time available to conduct the sequencing through pass sort, is relatively tight because the mail has to be handled early in the morning to the carriers before last mile delivery. As a matter of fact, this slide describes the critical times for the two-pass sequencing operation. Mail that can be held until the early start time of the pass 1 operation, at which point pass 1 can start. Meanwhile, mail for that zone can still be received and staged. However, it must be sorted through pass 1 no later than the latest runtime. This is the critical time by which the second pass, the sequencing pass, must begin for the mail to leave to the destination post office on the latest dispatch. This example illustrates the fact that because the second pass can only begin once the first pass is completed, let me repeat, but it illustrates the fact that because the second pass can only begin once the first pass is completed, the window of time available to sequence mail is relatively short, especially for mail that must be delivered overnight. As a consequence, that window of time will influence the number of sequencing machines needed to sort all postal zones into walk sequence. And we will be coming back to this momentarily. Another fact that also influences the number of machines required is the capacity of the bins in which mail gets sorted. This is best illustrated by an example. Let's assume that the density of mail delivered is 1.3. Let me repeat that. Let's assume that the density of the mail delivered is 1.3 mail pieces per address point. In other words, every street address receives 1.3 mail pieces on average a day. You can see on the top of the slide the formula by which you compute the number of mail pieces that can be sequenced into a bin. That formula shows that this number is a function of the density of the mail, in red in the formula, and the total mail sequence, which is itself a function of the number of bins, in green in the formula, and the number of passes, in orange in the formula. The table under the formula shows the number of mail pieces that will be sequenced in each bin after 1, 2, or 3 passes. As you can see in the example of a 100 bin machine, 1.3 mail pieces per bin are sequenced after pass 1. 130 mail pieces per bin are sequenced after pass 2, and 13,000 mail pieces per bin are sequenced after pass 3. Now, the typical capacity of a bin varies between 280 and 360 items. If we assume a maximum capacity of 340 pieces, then all the cells of the table that are in gray represent situations where the number of mail pieces sorted exceeds the capacity of the bin. This will create overflows, which will either cause the machine to shut, send the overflow mail to special purpose bins where it has to be refed, or require multiple operators to constantly sweep the bins in order to avoid an overflow situation. Thus, as you can see, the bin capacity is another limiting factor which, depending on the density of the mail, will also influence the number of machines required for sequencing a geographic area. Determining the number of mail machines, sequencing machines. As a summary slide, and one that is important to retain in devising a sequencing strategy, we review the two critical factors that influence the total number of machines you would have to acquire in order to implement your sequencing program. This number of machines will, of course, influence the capital investment needed and for which you must establish your business case. In short, the mail density and the bin capacity is one factor, and the operating window is another factor, which brings us to a discussion on sequencing strategies that will also influence your capital investment expenditure. So, some machine deployment strategies. There are three basic machine deployment strategies. A centralized deployment, where mail sequencing equipment is located at the destination processing centers. This situation is identical to the illustration we presented a couple of slides earlier, in which we presented the critical times and the importance of operating windows for a two-pass operation. Machines located at destination processing centers are dedicated to sequencing the mail for an entire geographic area, assigned to that sorting center. Consequently, the number of machines required will have to account for the total mail volume that will have to be sequenced. But there are also other factors that influence this number of machines, such as the space available at the processing center. A distributed deployment, which is shown on the right-hand side, in this situation, the sequencing machines are pushed further down the network and placed in depots or delivery centers. In our illustration, we call them destination post offices. These machines are thus dedicated to a few postal zones, and in general, they're smaller machines and operate with a three-pass sorting scheme. And finally, we may deploy a hybrid strategy, whereby machines are placed either at the destination center or at the destination post office. These choices depend on maximizing machine utilization. Thus, the more volume at a local zone, the more likely it may be to deploy a machine all the way down to a destination post office. I'll pass the mic now to Bernard Markowitz to discuss the next section on evaluating delivery point sequence.
So here we take a more macro level look at the factors that will influence the ability to successfully implement the sequencing strategy. This slide lists the components of a delivery point sequencing program. Each of these items has to be taken into account and eventually designed. I will mention them briefly. Address databases and updates. It's necessary to have a strong address database, and it's also necessary to have the mechanism to update this address database on a constant basis so that the actual walk in the street is synchronized with the way that the mail is sequenced. Second, it's important to have a mechanism by which walk sequences are input into a database in a digital fashion, so that also can be taken into account in the sequencing process. The third point is that since the window in which the carriers will be able to walk their routes will be increased, the postal operator must have the ability to update routes, create new routes that reflect now the increased time that's allotted for distributing on the street. As we have discussed, there will be a lot of implications in terms of windows and distribution and who does what in terms of the network processing part of the operation. The fourth point that must be evaluated, as Pierre also discussed briefly, is how much hardware and what type of hardware, including sorting machines and trays that are required to carry the sequence mail, as well as software such as sort plans and evaluating software must be developed in order to support the sequencing program. Implementation, there must be an implementation strategy. Delivery sequencing is not implemented usually in a whole swoop. It's implemented gradually, so there must be very strong project management to support the implementation. Another important element is delivery sequencing performance measurement. I think that the operators will want to know how the delivery sequencing is working out, how it's going, whether the sort plan are all doing what they're supposed to do. And so delivery performance must be measured for both machines and people. And finally, significant training is required both in the sequencing side of the operation and in the delivery side of the operation. It's important to assess where postal operators stand with each of these factors before evaluating and designing a delivery sequencing program. At the same time, as we said in the beginning, a delivery sequencing program will help postal operators address these issues and help transform the enterprise into a modern, disciplined, and efficient operation. Another very important requirement for implementing a successful sequencing program is the existence of a national address system. It can uniquely address these things. Here are other important issues that must be considered as part of the delivery point sequencing program. Labor cost and labor flexibility. Well, the postal operator be able to realize the labor cost savings that we outlined earlier in the presentation. Will the labor union flexibility allow for changes in the delivery carrier's work structure and in the changes that we have discussed? The second one is, does the postal operator have an addressing system and an addressing database? Is the address system in a good enough shape to be able to sustain delivery point sequencing? Level of automation. What is the level of automation of the postal operator? Are they already having a number of machines in their networks that are doing sortation? Is there a culture of automation in the postal operator that would facilitate the deployment of delivery point sequencing? An important aspect is what is the level of pre-sort and what are the mail mixes in the postal operator's mail volumes. Eventually, not all the mail can be sequenced, so that the postal carrier will have to merge the different mail streams before they can be delivered. So some casing work will remain no matter what. The mail mix and the level of pre-sort will give us an idea of how much work will be required by the carriers before they can go on the street. And the last point here is machinable versus non-machinable mail. How much of the mail that exists in the postal operator's operation can be processed on automated equipment, and how much cannot be processed on automated equipment because of shape or condition or other factors. So as we said, another very important requirement for implementing a successful sequencing program is the existence of a national address system that can uniquely identify each delivery point and associate it with a delivery route. Having a well-developed address system has become a necessary element of any modern postal service. We cannot really develop this concept now, the whole concept of address management, but we will be glad to discuss it with anyone that's interested. Cameras and optical character readers can now recognize upwards of 98% of typed or handwritten addresses. But mail pieces can be rejected by the sorting equipment because the address is not recognized in the address database. A solid program for address correction is very important. If the address is incomplete or wrong, the Postal Authority should develop a program to help its customers improve address hygiene. Many companies offer services or software solutions to improve the address hygiene of mailers. This process falls out of the scope of today's discussion, but it is essential to the success of your sequencing program. Another factor that we mentioned a couple of slides ago that affects the success of a sequencing program is the quantity and the size of the mail sequencing equipment. By size, I'm referring to the number of bins per machine. As we discussed, the capital investment in mail sequencing equipment will depend on the machine deployment strategy, whether it's centralized, distributed, or hybrid. It will also depend on the mail density and bin capacity. These factors will influence the total number of machines purchased and the related operational costs, which includes maintenance, supply, and operators. Non-machinable mail. This mail is mail that cannot be sequenced because it either doesn't meet the dimensional limits set by the machines or because it is of poor quality and gets damaged during the sorting process. Either way, this mail is transferred to manual sorting operations, which is to be avoided because the main intent of implementing sequencing is to reduce manual labor. Mail mix, which we've mentioned before, is a major factor to consider. You will remember that the goal of sequencing is to eliminate manual labor, to case the mail, and by doing so to reduce the time that carriers spend in office in order to increase time on the street and reduce the total number of letters that carriers have to process. Yet there are many streams of mail that cannot be sequenced and that continue to necessitate some time in the office. That includes residual letters that could not be sequenced by mail sorting equipment. We spoke of the various reasons that cause letters to be rejected to the manual sorting operations. We also have large envelopes, also known as oversized or flat mail. Today, few postal organizations have sequencing technologies for this type of mail, but the majority continue to case these envelopes manually at the post office. And finally, what we call saturation mail in the United States, which is unaddressed advertising mail that may be delivered to every single address point on a route by the carrier. And so this addressed mail cannot be processed through the automated delivery sequencing process. As you can see from the black and white photograph on the right, a letter carrier may end up carrying multiple bundles on his arm during his route. And all these bundles must be prepared at the post office before they leave for their route. This again reduces carriers' time on the street, which will affect the business case for sequencing programs. Several machines versus one machine. In configuring the hardware or in deciding which hardware to select, the operator will select one machine, can select one machine for each type of source. One machine for primary and secondary source, for standard mail, and one for flat, or one machine for standard mail sequencing, and one machine for standard mail sequencing, and so forth. Or, on the second row, one machine that will handle both primary source and sequencing for regular mail, and one for flat. Finally, it's possible to select machines that can handle everything. So they can handle primary and secondary source, delivery sequencing passes for both flat and standard mail. We talked about machine deployment strategies, whether centralized or distributed, and here's a list of the advantages and disadvantages of each. When you're centralized, you have fewer sequencing equipment that's required because it can be used for a multiple number of zones. So you have a higher utilization of sequencing equipment, and equipment can also be used for other types of sorts. So if you have multi-purpose machines, they can be used for primary and secondary sorts. Finally, maintenance is centralized. It all takes place at the plant. The negative point is that you have a very narrow processing window for overnight mail. You also have large demands for real estate in plants because these machines can have upwards of 240 bins or more. So they're large and you need to find place in the existing plant for them. The reject mail will be handled twice at the plant and at the post office. So it really depends on how much reject mail you have. Now, regarding a distributed strategy where you have the machines in the delivery units and the post office, the machines in general will be smaller and less expensive. The versatility also of these machines means that it can be used for other types of sorts, such as outgoing sort, primary outgoing sorts, and so forth. And generally, you will have a longer operating window to process the mail. However, more machines typically will be required because you cannot share the capacity of these machines across zones. These smaller three-pass sort machines are usually slower, so it will take more time to run the mail through the operation. And maintenance must be provided at the local level, so you'll have a distributed maintenance core maintenance that will have to visit these places on a regular basis. What are the sequencing pros and cons in summary? First, the office time savings is the primary benefit. In cases where you have 50 to 80% of the cost that are sunk in the carrier's in-office work, any reduction on that will be significant, but as we mentioned here, it will not necessarily be totally eliminated. Improved efficiency in principal sequencing standardizes the processes of street delivery. It really digitizes the carrier routes, and it provides the ability to inspect those and ensure that they are efficient. Sequencing introduces a program of standardization of trays and eliminates the use of sacks and other inefficient forms of containers. It improves accuracy because the automated sequencing is more accurate than the manual casing, and also it forces the digitization and a correction of a lot of the processes that are taking place. It reduces equipment in general by reducing the number of routes, carrier routes. It reduces the number of vehicles, carrier cases, and other equipment that's needed for each eliminated route. So the equipment for each eliminated route are eliminated, taken out. On the right-hand side, what are the cons, the disadvantages of mail processing costs? Obviously, as you saw, new costs are incurred because you have to acquire mail sequencing equipment. The second pass of the sequencing plan is a cost. You must have operators, you have machines that are running that must be maintained, and there is a cost associated with underutilized machines if, for instance, the operating windows are so tight that you will require more equipment. At the bottom, we list the address database, the need to have the address database both as an asset and a liability. So they span both the pros and the cons. The address database can help improve the sequencing effectiveness, can also help introduce new services such as the redirection of mail, but there is also a significant cost to maintain this complex type of database. implementing delivery point sequencing. How do we go, and we'll talk in the next steps about how to get there and how to decide whether to go ahead or not. How do we implement a delivery sequencing program? And here are 8 steps that we are suggesting that will lead a postal operator towards the implementation of delivery sequencing. First is assessment and evaluation. Is it worth doing? Once a business determination has been made to go forward, then it will be time to select a delivery point sequencing strategy. Centralized, decentralized, what are the implications on the network, and so forth. Once the strategy has been outlined, then it will be time for selecting equipment. There are, as we discussed, different types of equipment, and for each type of equipment there are different options. The number of rows, 2 rows, 4 rows, the number of bins, and so forth, that must be performed. And then once the technical requirements have been identified, then there's a whole procurement process that takes place. Next, system architecture and databases. So it's important to have a global view of how the information is going to flow in order to sustain this program and what databases will be required. Both address databases and other route databases and other databases required to sustain the process. When these 4 elements have been put together, now it is possible to put together a detailed implementation plan. What area of the country would we start with? How will the equipment be deployed, and where would the tests begin? How the evaluation would take place, and so forth. Another point is our infrastructure and distribution implications. Infrastructure meaning that some plants may have to be, some annexes of buildings may have to be modified in order to house the equipment, and the distribution may have to be adjusted in order to optimize the processing windows that would be required under sequence. Training, development, and delivery is an important part of it. There are changes both in network processing and in the delivery and the carrier's work that must be implemented, and training is very important so that everybody understands where they stand in the line of processes and what their function and objectives are. Finally, it's very important to put in place a performance management program that will take the information coming out of the machines and out of the delivery carriers' achievement to ensure that, number one, the routes that are in the databases are aligned with the carrier's walking sequence, and to ensure that the windows are adjusted properly and that there is not a degradation of performance service performance as a result of the program. Finally, next steps. We suggest 3 steps here in order to perform the initial assessment, the initial questioning of a delivery sequencing program. We call them assessment, business case, and detailed studies. And very briefly, we are going to outline what those entail. The initial assessment should be a look at what the postal operator is doing currently, and in a very general manner assess where the postal operator stands. The first question is, how much of an impact would a reduction in delivery labor cost, how much of an impact would the DPS program make? So basically the savings, the conservative savings of the in-office work that would be avoided by the DPS, how much of an impact would that make? Second question is, what does the addressing system look like? Does it exist? Does it have to be invented? Does it have to be put together? Or are there only minimal changes, or medium-type changes that have to be implemented? Third question is, what is the operator's current level of automation? Is sorting equipment already used in the system, or is the carrier not using any sorting equipment but using mainly manual processes? Is information obtained from this automation sorting equipment that can be used to assess the delivery of sequencing program in terms of identifying mail mix and machinable mail and so forth? Of course, that's the next question as well. What do mail volume and mail mix look like? How much volume exists today and how much volume is likely to exist tomorrow? And as we mentioned before, it is possible with delivery sequencing to develop new services, new programs that may likely increase the volume of mail. So that could be considered there also. And what does the mail mix look like as well? Because eventually only certain streams of mail will be able to be sequenced, and all these mail streams will have to be reconciled before the carriers can go on the stream. And finally, question of how much of the mail is machinable, how much of the mail can really go through the equipment and be sequenced out of the entire volume. So that's the initial assessment, and that would give us the primary idea of whether delivery sequencing would be feasible and worthwhile doing. If the answer is, well, yes, it looks like it would be very interesting for the postal operator, then we would go to the next step, which is establish a business case. And the objective of the business case, as you see in the last point on the slide, is to estimate the return on investment. So what do we have to do to get there? First, we have to perform a rough and conservative comparison of costs and benefits over time. So all the benefits of eliminating in-office carrier time will not come in the first step. It will come over time, and our experience shows how that develops over time. So that goes into that estimate. And then we need to have, of course, rough estimates as part of this comparison of the net labor savings, the other benefits that we mentioned, the hardware and system costs, and by that we mean the full life cycle cost, including maintenance and operators and training. Then we have the training costs and the implementation and management costs, implementation being changes in systems and databases, infrastructures, buildings, and so forth. And management costs would be the recurring cost of maintaining and implementing the program in addition to the machines. The other element of the business case is the evaluation of the risk. What if mail volume does not go up? What if mail volume changes over time or goes down? And what if there's less mail to be sequenced and so forth? That could be one set of risks. What if the effectiveness of the program is not as planned and so forth? And the evaluation of these elements finally gets us to the estimate of the return on investment. If the return on investment is positive, and if the postal operator decides to move forward, then a detailed study is required. And here we outline the main elements of this detailed study. The sequencing strategy must be elaborated and defined much more precisely. Exactly where is it going to start, how many bins, the size of the bins, and so forth. What will the distribution impacts and change be on the system? How will the windows of time be managed in the plants? Whether there's any contingency for that or not. What are the hardware technical requirements and the capacity of each? So this is the time to define this in a very minute way. What are the infrastructure and system changes required, and then the detailed cost analysis is performed to estimate what the cost of these, which infrastructure change and systems have to take place, and how much would it cost. A plan for the address management part of the program based on the current situation. We've talked about training before. Now it's time to develop a detailed program plan. And of course, there are various subsystems that are required, and each one of those will require a detailed study as well. We're naming a few here, such as video encoding, which is necessary to get to 100% or so, or close to 100% of reads on the address in order to sequence them all. What are the vehicular impacts? How many vehicles are needed? And so forth.